So the next topic is flyweight. So let us understand what is flyweight pattern. The module 1 we studied the definition. What actually the flyweight pattern does? It provides the interchange or the exchange. It provides the sharing of data between the different objects, correct? So what are the different sections we come across? Intent. How many sections we have here? Section 1 intent, section 2 motivation, then section 3 applicability, section 4 structure, section 5 participants, then 6 sample code, 7 collaboration, 8 consequence, 9 implementation, 10 related patterns. So there are 10 sections we discussed. Coming to the first section, intent. Intent means what actually it gives? It gives the necessary information about the issue or the problem going to be solved. So flyweight means we know it is used to share the data between the objects. So use sharing to support large number of fine-grained objects efficiently. What do you mean by fine-grained objects? You go for large set of data, but the amount of data is less. I have n number of objects, but the size of the data is less. That is called as fine-grained objects. So next we have motivation. Some applications could benefit from using objects throughout their design, but a nav implementation would be prohibitively expensive. Nav implementation means here the new implementation. Fine. So most document editor implementations have text formatting and editing facilities that are modularized to some extent. That means a document editor is already designed. It's readily available. Whereas in case of object-oriented document, editors typically use objects to represent embedded elements like tables and figures. So in case of object-oriented document, we go for embedded elements. Which are those? We go for tables and figures. Say for example, here we have a table. I need to insert a character in this table. See, in this example, I have considered around 3 rows and 1 column here. This is the column and these are the 3 rows I have. I am going to insert the character in the second row here. I have these characters to be inserted. The back of such a design is its cost. See, we can design whatever the client is requesting for, we can design according to the requirement, but the only thing is the cost. So we should be able to reduce the budget. So even moderate size documents may require hundreds of thousands of character objects. So we can insert any number of characters, but we have to go for a large memory space. So which will consume lots of memory and may incur unacceptable runtime overhead. So while executing, you are going to use what execution time is more here. So overhead is high. So a flyweight is a shared object that can be used in multiple contents simultaneously. So in order to overcome this, the cost, we need to overcome the drawback of cost and also the memory space requirement. So that's the reason we go for a flyweight pattern. So flyweight pattern provides access to the shared object in multiple contents simultaneously. That you understand with the help of the next 2 steps here. Multiple contents means we go for 2 types of state here. One is intrinsic state and second one is extrinsic state here. So what is intrinsic state here? Intrinsic state is stored in the flyweight. It consists of information that's independent of the flyweight's constant, thereby making it shareable. Intrinsic means within your system. Within the system, you can share the objects. So client will not know how you are sharing the objects internally. So that is called as intrinsic state. There is no condition in the first case. Whereas in the second case, extrinsic state depends on and varies with the flyweight's constant and therefore can't be shared. That means client cannot control your data. Client cannot share. Whatever they access now, they cannot share. So client objects are responsible for passing extrinsic state to the flyweight when it needs it. They can send the request. They are responsible only to same example what we discussed in the first slide, the row object, column and the character objects. Same thing. So I have taken a class name here as glide, where the operation, this is abstract class what we have considered. So I have the operations to be performed, draw the context and intersects with these values. What are those variables? Point and context. So I will go for this parent class is inherited to 3 children classes, one for inserting row and one for inserting column and one to insert a character. So now the operation, same operations I have taken in each of these children class. What are those? Draw of context and the intersects point and context of the variable. Same thing here in the character as well as in the column. Fine. So now these are the children classes with respect to the glide. Fine. So now we can what is this center one? The insertion of character. I have a character C to be inserted. Fine. So I will write a code to insert a character C. It is a concrete class. So the return value is character C, that is returned to the glyph, the class glyph. Fine. So a flyweight representing the letter C only stores the corresponding character code. Only C is going to be stored. So it does not need to store its location or friend. So here row and column I have not specified. Clients supply the context dependent information that the flyweight needs to draw itself. So client will decide which location that character C is to be stored. For example, a row glyph knows where its children should draw themselves so that they are tiled horizontally. Fine. So applicability. So a flyweight pattern's effectiveness depends heavily on how and where it is used. And these are the situation where we come across flyweight pattern. The first application here is an application uses a large number of objects. Whenever we want to go for sharing a data between more number of objects, that time we go for flyweight. So storage costs are high. Whenever there is a budget is high, to reduce the budget, we go for this flyweight. So most object state can be made extensive. Usually we go for extensive mode because we can share the data. What is that? Where is the client can access the data. Client cannot share, but intrinsic, we can share the data within the subunits. So the application does not depend on the object identity. So this flyweight application will not depend on the identity of the object. In subunits, clients are allowed to view all the subunits. They can access, but they cannot share. Structure, the same pattern, the same example. We have another diagram, the structure here. So I have the main class name here as a flyweight factory. Then I have a flyweight here. The operation to be performed is get flyweight key. So here flyweight factory will create an instance flyweight. This acts as aggregator and aggregator is flyweight. So here flyweight factory assigns a job to the flyweight. Now flyweight will perform with the help of two children classes. What are those? Concrete flyweight and unshared concrete flyweight. You can assume that one for intrinsic and one for extrinsic. So your return value is intrinsic state in the first one and return value in the second case is all state. That means extrinsic state. So client can access all these information, flyweight factory as well as intrinsic value as well as extrinsic value. Fine. So these are the participants I have. And I have the implementation part. So whatever the data you return now, for that code is given here. Fine. So who are the participants now? Flyweight is a participant, flyweight factory is a participant, concrete for intrinsic, then client is also a participant, then concrete class for unshared, the extrinsic is also a participant. So here unshared